Sometimes you'll be asked to find the angle between two lines. So we're going to do a two-dimensional example first, and then we're going to do a three-dimensional example. Of course, lines don't always intersect in three-dimensional space, so you'll only be asked about angle between two lines if they actually intersect. So in two-dimensional space, though, two lines will always intersect as long as the gradient is not the same. So in this case, the gradient is not the same because the two direction vectors are different. Therefore, these two linear lines will intersect at exactly one point somewhere. I'm not interested in where that is right now because I am going to be finding the angle between these two lines. So if you think about two lines and how they intersect, you're going to get two angles. There's going to be an acute angle and an obtuse angle. The only exception to that is if they are both right angles. Okay. So occasionally you'll be asked to find the acute angle between two lines, in which case you must make sure your answer is less than 90 degrees, obviously. So to find the angle between two vectors, think back to last year, we can use the formula cos of theta is equal to A dot B divided by mod A mod B. Okay, that is a way to find the angle between two vectors. And the vectors that we're interested in, well, there's four vectors in play here, but I'm not actually interested in the point on the line. I'm interested in the directions of the lines. So we could say that this vector here is the vector 1, 2, and this vector here is the vector 2, 1. So I want to find that angle. So it's the two direction vectors, the two coefficients of my parameters that are going to be used. So in this case, we're going to have 2 times 1 plus 1 times 2. So that's 4 for my dot product. Divided by the mod. So the mod of this is root 5. The mod of this is also root 5, so I get 5. And that then allows me to find theta. I don't actually have my calculator on me, so that's a bit embarrassing. Go on then, what's theta? Probably not. Could hire an editor. Sounds like money.
I have nothing else to do.
You have maths to practice. Thank you. 36.87 was it? Yeah. Lovely. Assuming that's degrees, not radians. So it's already acute, so that's fine. But I can tell it's acute because that's positive. Brilliant. There we go. So that's the angle between those two vectors. In 3 dimensions, first of all, you need to make sure that these two lines intersect. If you look at one of my previous videos, then you'll find that these two lines do intersect. They intersect when mu is 3 and lambda is 5 at the point 11 minus 2, 9. But the principle is exactly the same. So cos of theta is going to be equal to the dot product of the two direction vectors divided by the product of the moduli of the two direction vectors. So in this case, we're going to get 6 plus 0 plus 2, so it's 8 on top, divided by root 5 times root 14. And someone with a calculator will be able to tell me that that is... Oh, I've got two different answers. 13.02. 17.02. 17.02. 17.02. And that's the angle between those two lines. Ta-da!